Today, in this video, we will be talking about why we need IP addresses along with MAC addresses in networking. As you all know, MAC address is a very unique address for each and every computer or every electronic device that can be connected to the internet, and this MAC address is embedded into the computer or electronic device by the manufacturer of that device, right? So usually this MAC address is 6 bytes long, which means it is 48-bit MAC address. So this MAC address is unique to each and every computer or each and every device. But this MAC address alone cannot be used to connect to the cloud or the internet, because there is two major problems if we use only the MAC address for connecting our devices to the internet. Let me walk you through a scenario to understand those two problems. Let's say we have a network, and that network has 1,000 computers or 1,000 devices. Okay, I will take 1,000 computers. Okay, um, then if there are 1,000 computers, uh, there are 1,000 unique MAC addresses as well. In these computers, for 1,000 computers, there are unique 1,000 of unique MAC addresses as well. So let's say in that network, there is a computer A, computer B. This computer A needs to send some data over the internet to the B. Some data over the internet to the B. Okay. So for that, this computer A needs to know the MAC address of this computer B, right? This computer A needs to know the MAC address of this computer B. Therefore, this computer A has to store all the 1,000 MAC addresses of the network and then go through one by one and find the computer B's MAC address and send the data over the network to the MAC address of particular B computer. That's the scenario. The problem is storing 1,000 MAC address is fine. Let's say fine. The next problem is also the computer B has to store all those 1,000 MAC addresses as well in order to send the response back, because this B computer is also in the network, thousand computer network, right? So B also has to go through each and every MAC address and find A's MAC address and send the data, right? So that is a problem, because in modern network there are over 15 billion computers connected to the internet. So imagine a computer needs to store 15 billion, around 15 billion addresses in their memory will instantly run out, right? So not only one computer, each and every computer needs to store these 15 million addresses to communicate with each other. Therefore, we introduce a new address, which is a logical address called IP addresses. Let's understand the concept of MAC addresses and IP addresses with the use of real life analogy. Let's say we need to send a letter to one of our friend. What we do is we write the letter, put it in a letter cover, and then we write the NIC, National Identity Card number. Usually in Sri Lanka, it start with something like 2004-07 something something like that. Okay, National Identity Card number, and we write that and give that mail to the post office. Okay, to the post office, and the post office is responsible of giving the mail to the person. So this is the person which has the national identity card number, our particular number. Then what happens is This post office doesn't know anything about this person or anything about this person because we wrote the national identity card number, because national identity card number doesn't tell anything about the particular person or where the particular person lives, anything like that. Geographically it is nothing. Okay, so the post office cannot just give the mail to that person. And in the other hand, if we use the mail and we write the mail address, right? This is the address, this address. So what we do is we get the mail, write the mail, and we put the address of the geographical area or something like, let's say, Sri Lanka, Colombo, and Piliandala, let's say, something like that, and the house number, let's say, um, 21241, just for example. So here you can say there is a hierarchy. There is a hierarchy. You can go down the hierarchy, and you can identify the place clearly. We have first Sri Lanka, the geographical area, and then narrows down to the Colombo area, again narrows down to the Piliandal area, again narrows down to the particular house itself from this number. So when we give that mail to the post office, he can go to that particular area, particular house using the address and give that address to the particular person, right? So that way the mail can be delivered efficiently. Now let's map this real life scenario into the actual technical aspect, which is our MAC address and the IP address. So when it comes to the NIC, national identity card number, we can map it as the MAC address, and also the physical address as the IP address, because as we discussed earlier, MAC address is a unique address to device, as the national identity card number is unique for person to person. And it is also a flat address. It is also flat, because why we call it flat is it doesn't give us any information about the geographical location or the topology information. Anything like that it doesn't give. The even the MAC address or the NIC, it doesn't give any additional informations to us to navigate. In the IP address, in the geographical address, we call these addresses are hierarchical, because these addresses give us information about where to go. First, to let's say as an example, this geographical address, first it says where go to Sri Lanka, and then to Colombo, Piliandal, and then to the particular house. It maps to the particular destination, right? So these kind of addresses, we call them hierarchical addresses. That's why we need both, because let's say, as we previously discussed, let's say we are only using MAC address, this MAC address or the NIC address. In this real life scenario, we have to have save 2 million 20 million of NIC addresses to deliver this particular mail through just within Sri Lanka, because the Sri Lanka population is around 20 million, as I remember. That's how it works. So in IP addresses, when it comes to the IP addresses, uh, there are two parts. In IP addresses, there are two parts. One is the network ID, and then the other is the host ID. Usually the network ID is the front part of the IP address, which determine the network of the destination. As example, let's say we have we have a router. This router is outside of the network in the global network, and uh, we have a local network here, and we have a sub network here. So what we can do is, this network ID determines the local sorry this network ID determines the local area network, this network ID, and then we can use the host ID to get into the particular subnetwork. Because as you know, there are networks, and inside them there are subnetworks, and inside those subnetworks there are computers, right? There are electronic devices. So like that, these IP addresses are hierarchical. So I hope you understood what is the difference between the MAC address, why we need to have a MAC address as well as a IP address. So we will clear that more with this example. So let's say we have a home network A, which has a computer and a laptop connect through the router to the global network. I have drawn two routers in the global network, and then to the remote network we have to send some data. So these two servers join through this router 4 to the internet. So let's assume that this is the Google's local network, and then what I need to do is, from this laptop, from your laptop, we need to send some data to to this server. Let's say to this server, Google's server. So what we have to do is, we have to identify the IP address of this Google network, and then form the frame in this laptop, and then send it over here to the Google server. So let's see how that happen. So this is the first frame. Let's say frame, this is not the actual frame. Okay, this is not the actual frame format. I'm just taking the important parts out of the frame. We have source IP. It should be your laptop's ID, because you are the one who is sending the data. And then we need to have the destination IP, because destination IP is the one which the data needs to be sent, which is our Google's network. So then we use MAC address, source MAC address. So this for this transaction we use source MAC address, which is our laptop MAC, and then we use the destination MAC as router 1, because we are sending this data from here to here first. Because laptop first check the network whether this IP address is a is IP address of this network, but it is not IP address of this network, so it needs to send the data to the internet and then find the IP address by routing. So what it does is, first form the IP address, then fill this data, and this will be sent to the router 1. Then router 1 will forward to the internet, some router on the internet. Then the only the source MAC address and the destination MAC address changes. So here right now, the destination MAC address is the R2's MAC address, router router 2's MAC address R2, and the source MAC address should be the R1. This is the this this forwarding details, and then the R2 checks whether this IP address. So this part is the same. This part doesn't change. The this router 2 then checks whether this IP address reside in each network. So it is not. So it will forward that data frame, internet ethernet frame to the next router. So here also only the source source address and the destination MAC addresses will be changed. Here the source address will be R2 and the destination MAC address will be R3. So it is this transaction. Okay, so R2 to R3. Then this R3 will check again whether this check again the IP address and check whether that IP address is in his network, its network, but no. So it forward the data packet frame into next router. So here the destination source MAC address should be R3, the destination MAC address should be R4, right? So then this R4 checks whether this IP address reside on its network, its own network. So yes, the IP address reside on this network. So after getting the Ethernet frame into this router, this router also checks whether this IP address reside in its network, local network. So after checking, it identifies the network. So this is the network it should be. Now what this router has to do is find the particular MAC address of the particular server. These are one server, this is two second server, then there can be multiple server as well in the same network, right? So this router needs to find the particular net address, particular MAC address of the network, the server which this IP address resides. So to do that, this router put a request ARP request, which is the address resolution protocol request. We are not going to talk about this in details, but simply for we what it does is broadcast a message for every device in this network saying that we have send me the MAC address of the server, whatever this IP address hold. Okay, so this router broadcast that message, and this server, this particular server, after getting that message, since this server has that particular IP address, this server will send the MAC address of that server to the router 4. Then this router will send the network frame and the data to this server. That's how a particular data from a network go to the other network to the internet. Now I think you have a better idea of why the contribution of MAC addresses and the IP addresses in networking, how they contribute in uh, sending a message or data from one point to another over the internet. So let's summarize what we discussed. First, we discussed about the MAC address and why we cannot connect to the internet and do the communication using only a MAC address. So there are two problems. One is if we only use MAC address, we have to save each and every MAC address in each computer. That will be like 15 billion MAC addresses in one computer. That it is not possible, and also it is a waste of time. Even though we saved 15 billion MAC addresses, for in sending when sending data, we have to go through each and every one of those MAC addresses and search the particular MAC address and then send it to the other endpoint. So next we talked about the real life scenario, how we using national identity card as the MAC address, and also the address, geographical address as the IP address. And then we talked about how flat addresses and the hierarchical addresses help us in this sending mails over to a person, to a particular place over the internet, and in using post office and all. And then we went through a example together, how this your local area laptop send a data, send a data over the internet to a particular server. And then here I also mentioned that there is a ARP system, ARP request. In the next video we will talk about this ARP request, because this plays a major role, because since even though we know the IP address, since this computer knows the IP address of the destination, this computer doesn't save the MAC address of the these routers and these servers doesn't save the MAC address. So how these computers, these endpoints acquire uh, the MAC addresses is by using the ARP request and responses. So we will go through this ARP request and responses in the next video. Until then, thank you for watching.